Today we'll be talking about deploying a machine learning model as an API, and we'll use TF serving to do this. And we'll also test this out in Postman, see how Postman can make our life a lot more easier. But before I go any forward, could we bring up the slides? So, today we'll be talking about deploying your machine learning models and how you can make it easy or even make your first deployment. If you have never deployed a machine learning model earlier, well, I'll walk you through it and you'll make your first deployment today. You'll also see how easy it is to make a deployment. Because the bad news is that most machine learning models do not get deployed. And seeing the numbers, well, 90% of the machine learning models don't get deployed. And there are a million reasons for that, a lot of reasons for that. But in this talk, you'll see how we can simplify it. Another common misconception I've come across is that modeling is the main part, or creating a machine learning model, or probably defining a convolutional neural network, let's say for the purpose of this example, is the main part. But well, that's definitely not the scenario. If you see this diagram on your screen, a lot of other steps to bring it out into production and serving the machine learning model, deploying it, are a lot of cumbersome steps, but a major part of the pipeline too. So, hi, I'm Rishit Dagli, and real quick, a bit about me. I currently am a high school student, and also a three-time TED speaker. And I also love working with APIs, building APIs, using APIs, and I've also worked a bit with APIs. And I'm also a Postman Student Leader. I also love machine learning research. So, if you're interested in something similar, you might want to connect with me or ask me something about it. And my coordinates can be found at rishit.tech. So feel free to know more about me over there. So let's get on with the talk. But with that, let me just tell you who the ideal audience would be for this talk. It would majorly be people who have worked with some deep learning models and made a few themselves. And this could be with Keras too. You could probably have just built a very small deep learning model with Keras, or you could have probably subclassed a TensorFlow class and made your own custom deep learning network with all the jazz and stuff. Could be literally anything. Doesn't matter. And it would also be developers who want to take a leap from the machine learning models they built into a production ready manner and start serving their models to their users. So that would be the ideal audience for this talk. I would expect you to have built a machine learning model earlier, could even be curious. Yeah. So I've seen a lot of people asking me, including some of my peers, why do I really need to worry about machine learning deployments? And this is a very accurate representation of the ideal scenario. Your model works well or does a real good job in the testing or development environment. And when you bring it out into the real world or production is when problems start coming and things start failing. You need to be able to use your machine learning model on all kinds of devices, support using it on Android, on web apps, on Windows, a million other things. When you bring it out into the production environment, you need to have a resilient pipeline to serve your model and an efficient way to pass data and give your users what they want. Have minimum latency, support multiple machine learning model versions, and a lot more. So let's take a look at that first. Um, a couple of things you need to take care of to deploy your models into production. So first, of course, you want to get the model and package it in a way that you can use it in a production environment. You ideally would not put a Jupyter notebook in the same format into production, which you use for testing. You can if you wanted, but it's generally not advised to do so with a million drawbacks. And then you would want to host your model on some cloud hosted server or server in general. So your users can use it, provide them the model. Um, Now that you have posted your model on a cloud hosted server, you also need to maintain it, or a server in general. You also need to maintain it. One of the main things which I refer to while saying you need to maintain the server is auto scaling. You should be able to handle your users if you experience an increase in number of your users. This would also require you to increase your resources. Hopefully, you have many users from all around the world. So you'd also want to ensure global availability. But that is not it. Um, Make sure you have a minimum server latency, support multiple model versions, and a lot more. After this, you also need to provide a way for your model to interact with your devices. Most probably, you would need to provide an API to work with, some API which your users can call, uh, which your users can call, and it runs the machine learning model, gets the predictions back from the machine learning model, and also maintain this API. So tomorrow, when you make an update to your machine learning model, you need to ensure that your users get the latest version of your model. And we'll also talk about this in great detail in some time. These were a couple of things off the top of my head, which are super important to take care of when taking a model you have built earlier and putting it out into production. And there are a lot more, of course. But let's take a look at how you can deploy them. But before we get to TF serving and how you can deploy your own machine learning model, I want to show you an inefficient way to deploy machine learning models, or also what I call simple deployments. So here is a very simple setup for a Flask API. And I create an endpoint called classify, taking data from some user form, which has a field called feedback. Pre-process the data through some function, and then do a model.predict. And whatever I get, I will send it back as a JSON. And I just have referenced some functions called pre-process, and just taken in the data, but probably you would have a lot of code to do the pre-processing and all of that. But you get the idea where I'm going with this, with the simple deployments. A ton of blogs point out that this is a way to do model deployments, um, but you are essentially inconsistent over here. If I wanted, I could simply create a model with completely different API structure or standards. Nothing follows a standard process and is a bit inconsistent. You need to manage the model versioning all by yourself and maintain a proper versioning process too. I also want to use mini batching. I want to use my precious hardware optimally. And maybe by all this, you know that it's inefficient for huge models. You do not want to run out of memory or so. Okay, so what can you do? Well, that's where TF serving comes into place. Let's take a look at TensorFlow serving. A bit about TensorFlow serving before we actually get to deploy our first model. And just something at this stage I would like to talk about. At the end, you'll also make your first machine learning deployment today. I'll have a demo where we'll together make our first machine learning deployment. So if you haven't deployed a model earlier, there's nothing to worry about. We'll go through it. So TensorFlow serving is essentially a part of the TensorFlow extended ecosystem, which is a set of tools uh, which make uh, which make deploying your machine learning models or working in production super easy. Um, and yes, as I told, it's a part of the TensorFlow extended ecosystem. It is also used internally at Google to do machine learning deployments at scale. And yes, of course, it makes deployments a lot more easier, a lot more consistent. So let's take a look at TensorFlow serving now. The first thing we want to do is we want to package our model in a way that in a consistent manner, and we'll do so. As you might have guessed, I first want to export my model. What I can do is I can save my model as a TensorFlow 2 saved model, and all my graph definitions are stored as protocol buffers. And you can very easily do this with TensorFlow. Um, if you have a normal TensorFlow or Keras model, you could simply call tf.save model.save, give it the model object, and voila, your model is saved in the save model for you. But it provides a lot of customization capabilities too. Let's take a look at how the saved model would look like in reality. So this would essentially have a directory structure somewhat like this, and we'll go through this one by one. So first, I have the assets directory, um, which has my auxiliary files. These could be my vocabularies, and essentially all my auxiliary files. There, at this stage, I would also like to mention that there can also be an extra assets where higher level libraries and users can add their own assets that coexist with the model, but are not loaded by the TensorFlow graph. Uh, the extra assets is, of course, not managed by the saved model libraries. But for most models, you would just have an assets directory with all your auxiliary files. Next up, I have the variables directory, which has all of my model variables in a sharded format. So I have some question marks over here that is just to represent. This would be in a sharded format. So this would contain all my variables for the model. And finally, I have the graph definitions as a PB file, uh, which essentially just includes the graph definitions as metagraph def protocol buffers, and yeah, all your graph definitions are stored as protocol buffers. So let's take a look at TensorFlow serving now. Now that we have a trained model, we also have exported the trained model as a TensorFlow 2 saved model. Let's take a look at TensorFlow serving and how we can deploy our models with TensorFlow serving. The first line of this is super simple. I I just make a environment variable pointing to my model directory. So if you recall in the last slide, I showed you how the model directory looks like. So I just pass in the model directory, and and well will and when you see how you can version your models with TensorFlow serving, this might be a bit more clearer about how different versions of the model are taken from the same directory. That will be a lot more clearer when we take a look at model versioning sections. So let's break this. This is very little code. That is the first thing I see. And let's break this down. So first is me just running TensorFlow model server, calling TensorFlow model server to do its work. And next up, I give it the REST API port. So what I want to do is create a REST API for this. So I simply give it the REST API port I want to use. In this case, I have just put in 8501. And at this stage, I also want you to know that TF serving right out of the box for you also supports gRPC. So you can have a gRPC endpoint and a REST API endpoint very easily, which we'll soon talk about. Next up, I have my model name, which is probably just a semantic way of representing your model in a way you would like. This would also reflect in your model directory, in your model endpoint path, or the path from where you will be making an API call to the model. The model name would also be reflected in that. And finally, we have the directory where the model is stored. Since I'm talking about the directory where the model is stored, um, it is not essential for you to mount the file system. You can also directly get it from Google Storage. You can just provide credentials, and you wouldn't need to mount the file system. You can also have S3, the GCP or Google Cloud Storage was just an example. You could very easily also replace this with S3, just given your credentials and the same stuff. Now, I want you to take a look at this code. Super simple, right? We did write quite some code earlier to export our model and all of that stuff. But I want you to take a look at this code. This is super simple code, which we walked through, and you already have two endpoints. You have a multi-model configuration, uh, and all of that already set up for you. You could also do something like just add a new model in the Google Cloud Storage or the Amazon S3 bucket, and TF Serving will automatically fetch it for you. So this was some very little code, and TF Serving right out of the box created two endpoints for you. Super cool. So let's talk about, now that we have made a REST API, let's talk about how we can inference with it. And we'll talk a bit more about building this REST API. But for now, let's talk about inferencing with this REST API. So as I said at the start, to take a look at how you can inference from this REST API, or essentially just call it, You now have super consistent APIs. Let's say you make a new model tomorrow, you'll still have a super consistent API for that, and essentially all the work you do with deploying this model is super consistent. You have consistent APIs for everything. You also can easily support gRPC and REST APIs simultaneously, very easily with TensorFlow serving. And we'll take a look at gRPC endpoints real soon. And another thing I wanted to talk about while inferencing this, this might be super obvious and have a very clear intuition while working with images, but it might not be that clear when working with text data. So I thought to put this out, which is you pass in the data not as a list, but as a list of lists. This might be super obvious to folks who are working with machine learning quite a lot, uh, but uh, but just in case, I wanted to I wanted to explicitly mention this. I do make some mistakes while sending my data often. So essentially, what I mean is you don't have a list which you pass in, but it's essentially a list of lists. So you'd have one list with case one, case two, and so on in the list structure I show on the screen right now. So let's talk about where you would be making your prediction or where you'd be inferencing with. So the default URL is simply host colon 8501, which is our REST API port. You give the model name, or we specified the model name as test because I couldn't come up with any better model names. And best of my projects are named test or something like untitled. So I just had to keep it the model name as test colon predict. And there you have a default URL. What you can also do is you can also specify a particular version with this. So if you see the second example over here, I have specified it a particular version. So if I use the default URL, TensorFlow serving would automatically do something like fetch the latest version of the model and use that. But I could also explicitly specify a model version. Let's say I want to use model version 1 or 2 or so on. I could explicitly specify that too uh, with with this API, and you can see the URL for specifying us for explicitly specifying a model version. So in this case, I just make a super simple request, a super simple API request to the API we just made. And this is using Python requests to very quickly test this out, just in case you want to test this out. Later, we'll also be taking a look at Postman and how you can test this out with Postman. But essentially, it is super simple. You can see I'm just passing all of my data, which is a list of lists, as under instances, and just giving it out to my API, which then runs the model and gives me back the inferences. So you can see that we have indeed built a super consistent API for our machine learning models. What I also want to talk about is inferencing with gRPC. So in the last slide, you saw how we could inference with our REST API, which we just built, and which was super easy to. But I also want to briefly talk about inferencing with gRPC, uh, which which where essentially what you do is you specify each request type that you send. So you'd probably say this is a float, this is a string, and so on. And what this allows you to do is you also use something called a gRPC stub. You have RPC methods, and all the inferences you make are far more redundant than REST. Faster and efficient inference allows you to do faster and efficient inferences. And because you are also specifying all the data types, it also does allow you to do faster inferences. And using gRPC stubs, you can have better connections. Um, since since the data structures are not figured out in the server, you are essentially already sending them with the request. So yeah, all of your payload is also converted to base 64 before working with the gRPC API. And under the hood, what this simply does inferencing with gRPC is it converts everything to TF example records, which allows you to do this. What I also want to talk about is model meta information, which is super important in my opinion. TF serving also provides you a way to know some meta information about the models, which is really helpful. So you can figure out simple stuff like, let's say, which model am I inferring from, or which model does this API infer from. You can get to know about the data types the model uses, the inputs the model expects, the outputs you should be expecting from the model, and all of that things with the model meta information. So with TensorFlow serving, with the API we just deployed, we also have a model meta information API, which you could very easily use. This is also useful for model tracking and telemetry systems. And you can also see your model input output signatures very easily with the model meta API. And well, how do you use this? So you can probably see a similar URL on the screen, which has a get request signature. You just append slash metadata to it, and you get to and you just get all of your model metadata. Again, you can specify explicit model versions too. You can get input output signatures, data structures, and in all, this metadata API is super helpful, especially if others are using your machine learning model. And well, you might tell me, I could do this with Flask. I could pretty much do this with Flask. Of course, you wouldn't have consistent APIs, but with a lot of code, you could definitely do this with Flask. But the next thing, which I'll be talking about, batch inferences, because we love our hardware and we want to conserve our hardware, use our hardware optimally, is not something you can do with Flask, or probably you can, but with a lot of code. I've never tried out batch inferences with Flask, um, but uh, but as far as I know, you couldn't do batch inferences with Flask, even with a lot of code. So the idea behind batch inferences is super simple. I want to use my hardware efficiently. So what I'll be doing is I'll take multiple requests and process them together. This would also allow me to save costs and compute resources. And especially if you have a large machine learning model, this is super cool. Batch inferences is definitely something you should be doing. So batch inferences with TF serving is super simple. You can just create a file called batching parameters.txt, and this is highly customizable too. You can do quite some optimizations in this. So these are a couple of optimizations on the screen, but uh, just a couple of super useful optimizations in from my experience would be you can also control how your the polling for new models, which is essentially saying that let's say I have my model stored in a Google Cloud bucket or Google Cloud storage. So polling for new models or checking if a new model has been uploaded on Google Cloud storage might incur me quite some costs. So I can also change the polling time and say something like check for a new model every 30 minutes or check for a new model every 60 minutes and so on. You can also change threads for TensorFlow session, the number of cores used by TF serving, and you can make quite some optimizations with this. So using batch inferences is also super simple with TF serving. So we made a batching parameters.txt file earlier in the last slide with quite some optimizations I could make to do batch inferences. I would simply load this configuration file on startup. And yeah, of course, I think this was super self-explanatory, but feel you can also change the parameters in batching parameters.txt according to what you need. So just load this txt file with all the configurations on startup and use the flag enable batching equal to true to write out of the box support batch inferences. And that is pretty much about my talk. But I also want to, but since we are talking about machine learning model deployments, I also want to talk about a couple of more things. Probably if you want to use non-TensorFlow models with TF serving, you could very easily use Onyx, which is an exchange format, and have their own runtime engine. So you could use TF serving and also deploy a PyTorch model super easily. But feel free to take a look at some other deployment methods. So you can take a look at Kubeflow deployments, which support entire machine learning pipelines, sophisticated A/B testing. A wonderful package which I recommend to use called Istio for cool A/B testing and model routing. You can also do something like data pre-processing on server using TF transform, which is a wonderful package. And what it does is converts all of your pre-processing steps as graphs and connects them to the model itself with TensorFlow serving, and deploys all of them as a bundle to prevent misalignment. And you are essentially offloading all of your pre-processing work to the server. You can also take a look at AI platform predictions, which is just a wrapper around TensorFlow serving, what we took a look at today. And because we were talking about deployments, not entirely related to building APIs, but you could also take a look at, if you're interested in machine learning deployments, take a look at deploying on edge devices or running your machine learning model on a mobile phone and federated learning. These are the slides for my talk today. And now what we'll be doing is we'll come to the exciting part. We'll be doing a demo. So in this demo, you'll make your first machine learning deployment and use Postman to test it out. And don't worry, we'll do everything on Google Colab. So you don't have to install a single thing to follow with this demo and make your first machine learning model deployment. Could we have the demo up? Let's get started with the demos. And I'll first move on to my screen where I have the Postman workspace, where everything starts. From here, I'll open up the documentation for this. And I'll show this demo in a way which you can go about it, reading through the docs and following all what the docs say. So let's try to do this in that way. So this documentation essentially tells me that I'll be doing all what we talked about in my talk and running it live in Postman Collab, in Postman using Google Colab. So this tells me that I can do everything for hosting the API and building my own API for this smart app itself. What this means is you essentially don't have to download a single thing on your own machine. You can do all in the web. So just click this link and you'll be off to start on Google Colab. So let's go to my Google Colab screen. And over here, this is just some basic Python code, import TensorFlow and all of the dependencies we need. So first what we'll do is we'll take this data set, the FashionMNest data set, which has 70,000 images in 10 categories. And these are 10 fashion items. So these could be an ankle boot or a pullover, sweater, stuff like that. You get the idea. So the goal with this notebook is to not to show you how to train a model, but is to show you how to deploy a model. Quickly go through the training code once. So here is me making a super simple model, a super simple TensorFlow model. This has just one convolution layer, one dense layer. That's literally all this model has, and I'm training it for just 5 epochs. Now our model is trained and it gets a testing accuracy of 88%. And you tell me, wait, you can do better than this on the dataset. And yes, I agree. But one of my goals was to do the training as quick as possible. So if you see, the training does not even take a minute to run. So I just wanted to make this easy to try out. And our goal is not to build a very, very good model. I could easily do that. But my goal is to show how to deploy a model. So we have a quite good model which gets 88% accuracy on this simple data set. So now we'll go ahead and save this model. We'll save this model as a TensorFlow saved model, like we talked about. So let's save it in my temp directory. So it tells me that it has saved it in /tmp/1. So let's just go to that directory in Google Colab and see if see if what I was talking about, and about how a TensorFlow saved model is saved. Let's see if that follows. Well, it should follow. So I have a folder called one, which is the version of my model. And under this, I have assets. There are no assets for this small model. I have variables, which has all of my weights. And I have my saved model.pb, which is my real graph definition file. Now let's get to the part we are excited about, serving the model with TensorFlow serving. So first, this cell installs TensorFlow serving in Google Colab. As I said, everything will be done on Google Colab. You will even host your API on Google Colab. And so let's first download TensorFlow serving. Now we have TensorFlow serving installed and we are all ready to start running TensorFlow serving. So let's set our model directory, which is just where my model is stored. Remember the directory I showed you earlier. And now we'll start our TensorFlow model server in the background. I'll give it the REST API port 8501. My model name, I'll call it as fashion model. This will also be a part of the API base URL as we talked about. And I'll give it my model base path, which is the model directory I set up earlier. And I'll use the TensorFlow model server. So let's run this. And this has now started in a separate thread on localhost 8501 inside Google Colab. Let's see the server logs. I should have got something saying this was started, and yep, it is essentially serving at localhost 8501. So now I'll go back again to the docs. This is just some code if you want to test this out in Python itself. But now I'll go back to the code, and this says if you're running this demo on Google Colab, be sure to add this little piece of code, which allows me to make this API I made on Google Colab available to people outside of Google Colab. So let's do this super quick. Let's paste this. And so this was also one of the things which I thought about when writing the documentation. You should be easily able to just paste code and get running. I now go back to my Postman workspace and run the demo. I call my API right now. I have this thing called base URL. Base URL is essentially what I want to edit. So I'll go to my collection. I'll go to the variables and I'll edit the base URL with my ngrok URL. This is being run on my own Google Colab. You'll probably make a fork of this and try out all of this for yourself. Here it is. Here it is. I did edit the variable to have the ngrok URL. Now I go to a pre-made request I've made for you all. I have a body which says which signature I want to use. I want to use the serving model. And I also have instances which may seem like a couple of numbers, but this is just an image in terms of its pixel values, which is essentially what I've entered over here. And I've not only entered one image, but I've entered 3 images, as you can see. What we'll do is we'll send over a request to our API hosted on Google Colab, and it should work well. Let's see the response. Okay, it did work well. This is JSON, so Postman did all that beautifying stuff for me. Super cool. And I got 3 outputs in the predictions tab. This is the output number 1, and when you'll be using this API, you'll probably be calling this from Python and let Python make sense of all of this. But I really wanted to show you. You can also write some Postman visualizer code, by the way. You can just go to tests and write some cool Postman visualizer code. But I wanted to show you by hand how this works. And just to show you the model API does correspond with the one we were using when training. So I have a cell in my notebook over here. Let's run this to see the 3 images we passed in. Remember, I had passed in 3 images. So this is in order, the 3 images I passed in. So the documentation also tells me that the API returns a list of probabilities of predicted classes. And so these classes will help you out. So what this is essentially telling me is all of these are probabilities the model thinks for each of the classes. So as I said, you'll probably have a Python script which does all of this, but I wanted to try and do this manually to show you once. to make sense of this. So I have the highest probability uh, in the in the last entry in the first image. So what the last entry or the entry at number 10, this is this is starting from number 0. So the entry at position number 10 corresponds to an ankle boot. And let's see what our first image was. Well, this was an ankle boot, so our model did good job. Let's do this for the second image. For the second image, I have the highest probability. I'm doing this by hand again, but we'll probably have Python do all of this for you. For the second image, we have the highest probability in our in the third entry. And what the third entry means for this is the second one, because this starts from 0, right? What the second one means is a pullover. Let's see what my second image was. And whoa, it is a pullover. My model is doing great job. Okay, so yeah, I can also do that for the third image, but I'm pretty certain my model has done a great job. So try this out for your own images, and that was all about the demo. I have done some work writing good docs, so you can just copy paste stuff from here. Just copy paste stuff from here, make it work on your own models, and all of this runs on Google Colab, so you don't have to download a single thing. That was all for the demo. So that was all about my talk, and I hope you enjoyed the demo. Feel free to try this out on your own. And if time persists, we'll take some questions. I'll leave that on the list.
Wow, Rishit, that was extremely thorough. A very, very, very deep introduction to machine learning. Thank you. For those of you like me that don't know a lot about machine learning, you'll be happy to know that there's recordings of these sessions later. So join us in our Discord and you'll be notified if you'd like to take a nice slow rewatch and look at the links on your time. We have a very short amount of time for Q&A, but we have a couple questions for you, Rishit. The first is, what are your recommended resources for getting started learning machine learning?
So if I talk about myself, I took a look at machine learning from first learning some high school math, which I was already exposed to in school, and then I started taking up research papers, and I started taking a look at Stanford and MIT lectures. Those are really good. That is how I got started into machine learning. So if you have a good math base, just high school math, simple high school math, I would definitely recommend you to take a look at university lectures.
And how were you able to watch university lectures?
So often in the case of MIT lectures, you have something called MIT courseware. For most of the Stanford lectures, which I watched, they were uploaded on Coursera, which is a quite popular website to share courses and videos. So, and usually you can find a lot of them on YouTube too. So I definitely recommend taking a look at university lectures. Those really helped me understand the basics and do a lot of stuff in machine learning.
So there you have it. Get online and watch some university lectures to get started with machine learning. Rishit, thanks again so much for your very in-depth demonstration, and we're looking forward to reading the documentation ourselves.
Thank you. It was fun.